Okay, I got trying to prepare the slides, so this won't be any hands-on session. And as confirmed, even I guess Keertana and Joe, they both don't have the Kubernetes enabled in their local system, so that's okay. We'll just go on with the presentation, and at last I'll show the demo. And in between, I'll also show the steps of how to spin up a cluster in your local itself. Okay, let's start this session. So the agenda, I'll be on a high level introducing MLFlow because most of you would have you are well versed with MLFlow and you would have tried it already. So I'll be just introducing it. After that, I'll also show some of the steps on how to set up the MLFlow server on a remote host like EC2, and as well how to configure RDS database in AWS and try to give the link of the database to the MLFlow server so that it tracks all the metadata. Apart from that, I'll show the steps on what all things are to be installed before launching a Kubernetes cluster in your local, and after launching the cluster, what are the things that you need. After that, I'll give a brief overview of Seldon Core. Seldon Core has lots of concepts. Uh, the ones that are relevant for our discussion today is like these three that I mentioned. Pre-packaged inference servers, Canary release, and the monitoring metrics with Prometheus and Grafana. So apart from this, we have a lot of things like explainability, outlier detection. Uh, Apart from that, what else is there? Drift detection. So there are and distributed tracing. All those things are there. Maybe we can take up each of those as and when the requirement comes up. And finally, I'll show the demonstration for MLOps pipeline with all these included. MLFlow, Seldon Core, inference servers, A/B testing. Apart from that, I'll also show the Prometheus and Grafana dashboards. Yeah, this slide, I guess most of you would be aware of. The experiment tracking, model reproducibility, central model registry, and pipelines. So MLFlow, I guess these for whichever it's shown in the below diagram. These were there from a long time. But the additional thing that was added very recently, maybe a month ago, was the pipelines. So these pipelines is almost similar to Kubeflow pipelines or Daxter pipeline, whichever Stephen you have shown now. Maybe the functionality or the kind of support that has been provided over here, it is still experimental. So we need to still see how far it is beneficial when we talk about production pipelines. Okay, next is these are the steps to set up the MLFlow server in EC2 instance. So first is to spin up an EC2 instance. That's depending upon our needs. We can spin up whichever configuration of EC2 instance. Right now, it is just a small instance that I have to spin up, which has maybe 2 or 4 virtual CPUs with 8 GB RAM. Since this is just for our local testing. But as and when the requirement is huge, we can deploy this MLFlow server in a bigger EC2 instance. So once you spin up the EC2 instance, you can launch the Postgres DB in not EC2. This is RDS. Oh, I'm not able to edit this. Okay, that's fine. This is RDS. Here, when you see, this is the AWS service for databases, relational databases. So once you spin up this cluster for a database, you can get this particular endpoint and the port to access this database. So you are supposed to just mention this endpoint along with the port while running the MLflow server, so that it points to this and tries to store all the metadata over this particular database. So I guess right now it is not in use. I'll just stop this. Yeah, so this particular instance is db.t3.micro. The cost is very less, $0.017 per hour. Uh, so even these instances we can change according to our needs. Yeah. So once you launch the DB in AWS RDS, you need to point out. So here is the command. So this is a command where you once you install all the dependencies for MLflow server, you can enter this command in your EC2 instance or local wherever you want to run it. By configuring the backend storage URI. So here, instead of this URI, you are going to mention the endpoint that I showed for metadata storage. And artifact storage, you can mention the S3 bucket link, whichever you are trying to store the artifacts. So once you enter this command in your EC2 instance, it will start running this MLflow server. So you can access the tracking and all by using the EC2 instance's IP address along with the port in which MLflow is running. So,
sorry, quick question. And how about the port? Where do we enter that?
Port is usually, it runs on port 5000. So here, let me show this. What was the instance? Where is it not showing? Oh, it is not. Okay.
Yeah, maybe because of the other filters. Yeah.
Yeah. So here you need to go in networking at the port that you want to access. Where did it go? I guess it's security. Yeah, here I have added the port 5000. So usually it would be the default 80 and 22 port, which will be open for public to access the EC2 instance with these ports. But whichever port that you want, you can add it. I guess you need to go to security group, edit inbound rules. Okay, so here you need to add whichever the port that you want to access over here. So once you add this, you will be able to just use the IP address of the instance along with this particular port to access the tracking server.
All right, got it.
Okay. After this. So any questions till now?
No, nothing from myself.
Okay. Yeah, the next thing is the steps to launch the local Kubernetes cluster. So here, I guess I'll just show where you need to go. So you would be having Docker desktop. Here in preferences, you need to go to Kubernetes and just enable this. So once you do this, it will install all the images and run the containers that are needed for the Kubernetes engine to run. So once that is done, everything is set. After that, we can spin up a cluster. So these are different things which has to be in place. So first thing is so obviously Docker I have told it. After that, command line tool. So this one has to be installed to spin up the cluster. After that, kubectl, anyways, you would be knowing of this command line interface to modify or delete the Kubernetes clusters or resources. And Helm is a package manager to basically install everything in place for launching the Kubernetes cluster. So all the packages the Seldon Core, which I'm discussing right now. So if you just mention the Seldon Core operator or analytics, whichever package you want, it will just try to install all the requirements that are there for that particular package. So if you do not use Helm, it is like you manually enter kubectl commands to deploy a particular module. But Helm is handy, like it comes with everything, all dependencies in Helm repositories. So it knows for a particular module what all things dependencies are to be installed. And apart from that, till the step 4, once you are done till step 4, you can start to create a Kubernetes cluster using kinds command line interface. After that, once the cluster is spin up, I guess I'll show. So here you can see the context. There are currently 3 connected Kubernetes clusters. So these 2 Docker desktop and kind Seldon, these 2 are in local, and care test cluster is this AWS based Kubernetes cluster. So with all these credentials and the context, everything would be stored in your local files. I guess I will show you config. So as and when you create the kind cluster, it will try to store all the information over here as well. So you can see the cluster, what is the server and port, which it will be running on, context, and the current context, you can set it up. So it might be pointing to Docker desktop initially, but as and when kind cluster has been spin up, you can set the context so that it refers to kind cluster. And these are the list of users for different clusters.
I actually share, like, is there any permission or is there any group that you were added to so that you see a particular set of Kubernetes cluster? I see a lot of them, like production, prod stage, and things like that. My list: care, prod, EU.
No, you might have the access to Kubernetes cluster in all those deployments. I just have it for care test, I guess.
Okay.
Yeah, I also have more different clusters, also like what does it say? I already forgot the names. Like the care prod, EU, and a couple others.
Yeah. So whichever cluster you have access, you can switch to that context and try to deploy. But I guess you might do that only in care test. Apart from that, you might not have permissions to deploy on your own in any of the other prod-based clusters.
Yeah, and care test is actually the only one that we're using. So that's fine. Yeah. And when it goes to production, then we can also check the logs in that Sumo Logic.
Sumo Logic, yeah. Okay. And apart from that, once you spin up the Kubernetes cluster, if we need to install these particular dependencies, that is ingress controller. Basically, there are 2 controllers, that is Istio service mesh or ambassador. So these ingress controllers are very important because whenever the requests are hitting the cluster, it is not very safe enough to directly send those requests to the inside the cluster. So there needs to be an API gateway which tries to authenticate and authorize the incoming requests inside the cluster. So ingress controller does that, and apart from that, it also tries to route the incoming requests into the cluster depending upon the kind of model or service that is deployed. So usually in the cluster there would be lots of namespaces and lots of container spots in which many models would be deployed. So the ingress controller would have the knowledge of where a particular incoming request has to be routed to in order to get the correct predictions. So all those orchestrations are maintained by ingress controller. So this has to be installed. So there are Helm packages available for ISTO and Ambassador. Apart from that, you need to install Seldon Core Operator, and Seldon Core Analytics. So basically, Seldon Core Operator is the one which does all the kind of orchestration. So you can say that as the brain of the total Seldon Core module. So it can manifest everything that is based out of Seldon Core. So once you create this cluster and install all these dependencies, you need to have this Seldon Core operator installed in a particular namespace. And all the Seldon Core related deployments has to be in that particular namespace, wherever this Seldon Core operator is present, because this is the one which manages all the deployments of pertaining to the Seldon Core. And you need to so there needs to be basically two namespaces, one for Seldon Core and one for Seldon Core Analytics. So in analytics, you would be like this is a package which by itself installs Prometheus and Grafana. So Grafana was there before, but right now it has been removed from this analytics package. So you are supposed to install Grafana on your own. Once this analytics packages are installed, like this package is such that all the configurations are done in place. Like Seldon Core deployments, whatever the metrics are there in your deployments or production for related to Seldon Core models, everything would be traced and tracked by Prometheus and displayed in Grafana dashboards. So all those configurations of how Prometheus has to scrape the metrics for a particular deployment in your Seldon Core models would be like in place configured if you install Seldon Core Analytics package. But if you try to install Prometheus and Grafana on your own without using this analytics package, then you are supposed to do the configuration by yourself, which is a bit tedious process. Into the next slide. So this is a basic overview of Seldon Core. So here you can see the particular roles that are being played by the data scientist and software engineer. So software engineer is basically taking care of the ops pertaining to the MLOps pipeline, and the data scientist is working on the data engineering and model training pipelines. So here you can see a lot of frameworks: Spark, XGBoost, MLFlow, TVC, TensorFlow, scikit-learn, everything. So there are pre-packaged inference servers for all these libraries. So MLFlow or Spark or XGBoost, everything inside Seldon Core. So if you train a particular model in, suppose, TensorFlow, so there is no need for you to mention the requirements.txt file at all. And there is no need to prepare a Docker image as well. So that is the kind of advantage that you get with the pre-packaged inference servers. So all the dependencies, basic dependencies that you require for a particular framework will be installed in place as and when you deploy that particular model. So you are just supposed to define a model class, which initializes all the hyperparameters and the model files. And you just give the predict function in your model class, what it has to, like what should be the input to that particular predict function, and how the output should be. So if you just define that, this prepackaged inference servers will take care of everything. So apart from that, so I guess these are the templates on how the model file will look like. As I mentioned, this is a model class that you define, load the particular trained model, and give the predictions based on this predict function. So just if you have this particular Python file, like while deployment, all things will be taken care of with the pre-packaged inference servers. I'll explain these a bit in detail in the next slide. So once you have this particular model trained and this model file in place, you can use the same for deployment by mentioning all the details in the deployment.yaml file. So once you deploy, the Kubernetes will try to fetch all the details in this YAML file and tries to deploy your Seldon model in that particular namespace. Since I showed you the, I mentioned the details of this Seldon Core operator, right? So here you can see Seldon Core operator. So here, this is the operator, and it has the complete control of the Seldon deployment. So Seldon deployment, it will be having the pre-packaged inference servers, the model files, as well as the orchestrator. So the orchestrator is the one which tries to route whatever the incoming requests that are coming from the ambassador or STO service API gateway, and it will try to route it to these particular Seldon models that you have deployed. And as since I mentioned, the metric scraping is from Prometheus, and you can view these metrics using the Grafana dashboards. Apart from that, you can view the distributed tracing using the Jagger client. So maybe as we'll discuss like briefly on this in upcoming sessions. Any questions from this slide?
Nope, I'm good. Maybe Joe or Kita?
No,
Yeah.
some
Go ahead, Kidma. Yeah, so for me, it's fine.
Okay. So this containerization was the one that I was talking about in the previous slide. So when you have these pre-packaged inference servers, so this is the you have two ways. Like you can containerize. I guess I had mentioned about S2I almost 4 or 5 months ago. So you are just supposed to give the requirements.txt file and this environment file. So there is no need of Docker file that you usually use while building the Docker images. So source to image, which has these predefined Docker images, they try to use this and the details that you have provided over here to build the Docker image. So apart from this requirements.txt and this environment file, you are supposed to give this model file. So this model file is the same as this particular model class file that you have defined with the predict function. So if you just give these three files, a model class file, requirements file, and the environment file. So environment file, it just defines what kind of API it should be, REST or gRPC protocols, all those things you can configure over here. And the model name, which I have defined in the model class in this Python script. All those things you need to mention over here. And the Docker image will be built based upon that. So this is basically, you can tell this as a wrapper, language wrapper or a Seldon Core wrapper that you give while building the Docker image. So for this, you need to install this SDI command line tool. This is OpenShift's interface. So once you install this, you'll be able to do the containerization without Docker files. I guess. Yeah. Okay. So coming to this, this is the deployment file that you try to use once you have the Docker image. So here you can see the YAML file with all the this kind is Seldon deployment. So this is mandatory. So like you can you'll mention this kind parameter as the pod or the service or deployment, right? So since Seldon is a CRD, that is a custom resource deployment, you are supposed to mention this particular thing that is Seldon deployment, so that Kubernetes will understand that this is a CRD, and everything related to Seldon deployment has to be present in that particular namespace with all the dependencies. So once you mention these API versions and the kind of the deployment, and apart from that, you might be aware of all these, the predictors, what kind of containers has to be downloaded and installed in the pods of this particular deployment, and which are the parent and the children of these particular containers. So here you can see there are 4 containers, that is input transformer, my model, classifier, and model combiner. So here you can see my model, input transformer, and model combiner. So once you specify all these containers, it will try to download using a initializing container. After that, in the graph, here you can mention the routing of each of these containers, how the data has to flow between these containers. So here you can see the input transformer is the parent, and the rest of all the 3 containers are the children of this particular input transformer. The combiner or this my model. So all these are and the classifier. So my model and classifier are the children of model combiner, and these 3 together are the children of input transformer. So here this implementation. So here you can see I mentioned it as a SQLN server. So these are the prepackaged servers that I was talking about. So if you have built a model based on, suppose, XGBoost, you can mention this as XGBoost server. If you want to use it based on MLFlow, you can use mention this as MLFlow server. So there are different types of servers. Hugging Face server is also there. So based on the framework that you have built in, you can just mention it over here. And you need to mention the model URI as well. So wherever this particular model artifacts are stored, it might be Google storage buckets or AWS S3 buckets, which are it might be. So once you give this model URIs, you are also supposed to tell the Kubernetes about the authentication. Suppose you give a AWS S3 bucket link, but your Kubernetes local might not have the credentials to download the artifacts from that particular link. So you are supposed to mention all those in secret files. So in secret files, you can mention all the configurations. I guess I had done that. But, oh, I guess that has been deleted. Okay. So once you mention all the secrets, the artifacts would get downloaded without any hassle. After that, the containers will spin up, and they'll be running in all the pods that has been deployed. So the prepackaged inference servers. So this is the main difference. So the S2I functionality that I showed before, those are non-reusable model servers. And reusable model servers are the prepackaged inference servers that I mentioned in the previous slide, the SQLN server or MLFlow server or TensorFlow server. So here, what happens is, in non-reusable model servers, you would have supposed to build a Docker a Docker image using S2I functionality. After that, you would have published it to Docker Hub. So what happens is, in deployment, every time these images would get downloaded from the Docker Hub. But the difference with reusable model servers is, so irrespective of suppose in non-reusable, you're supposed to train maybe 5 or 6 XGBoost based models. Okay. So for all those 5, 6 XGBoost models, you are supposed to build different Docker images. So there will be around 5, 6 Docker images. But in reusable model servers, even when you're dealing with XGBoost model, you have a XGBoost server, which is pre-packaged by Seldon. So you might require only one server which can be reused 6 times. So that is the kind of effort that has been put between these two reusable and non-reusable model servers. And here, right now, you might be using Docker Hub to push your images, but as and when the complete ecosystem is in AWS, you are supposed to migrate all your images to AWS ECS container service. So there will be a cost associated to that as well. So if you have thousands of images, there will be a lot of cost that will be burden for you. But that can be reduced a lot by using reusable model servers, where there is no need to build a Docker image or store it in with respect to any kind of cloud service. But as mentioned over here, both are useful and relevant in different contexts. So it is like right now, Seldon just provides 4 or 5 pre-packaged inference servers. But as and when the models become complex and it uses several other frameworks, suppose it might be a combination of scikit-learn or XGBoost, or it might be a combination of MLFlow as well as Hugging Face and TensorFlow, PyTorch. So when there is a combination of multiple things, then these prepackaged servers might not be useful. So in those cases, obviously, you need to go with the second route, that is the S2I. So that is what they have mentioned over here. Any questions till now?
I have one the whole setup you have done locally, or there is any connection like we will be using VPN or AWS RDS or anything like that?
No, VPN is not necessary right now. I have done it everything in my local. I have not gone to AWS EKS. So once I migrate to EKS, I'm supposed to have a VPN connection, and nothing would be possible if I have a VPN connection.
Okay. Okay.
Oh, I guess this will be a 1 hour session. Okay. The next one is the Canary or A/B testing. So here, this graph might not be completely depicting what the heading says. So the first one is the inference graph. Suppose you deploy a particular Seldon model without any Canary testing, A/B testing, or outlier detection or explainer or anything. So this is how the graph will look like. So the user sends the request and it will directly reach the model and he'll get back to predictions. So apart from that, this is another example of a complex Seldon Core inference graph. So here, this multi-arm bandit is similar to this Canary testing or A/B testing. So these are just different methods on how you route the incoming requests to different models in different proportions. So here, suppose you have different versions of model. Suppose model A is already in production, and you get model B and model C as improvements to model A based on some criteria. So you want to test it out in production. So you try to route the incoming traffic to maybe 70 to A and 20 to B and 10 to C. So these proportions you can decide you are supposed to. So in A/B testing, what happens is suppose you have these two models, or suppose all these 3 models are there. You try to distribute the traffic equally to all these 3 models. So in Canary, what it does is a model which is in production takes the highest load, and those which are yet to be in production, which has to be tested on production traffic, will take the lowest load. So that suppose the agenda on which model B and model C has been built, suppose it has not met the criteria, you can just roll back the versions and try to work on it before it gets to production. So that's how the basic difference you can see with A/B testing and Canary. So in A/B testing, suppose the model B and C did not work out as expected, a majority of users in production would get affected because of that, right? So that's why that is a basic difference between these two strategies, A/B testing and Canary. You just want very few users to be exposed, and only after you are very confident that it is working as expected, you try to increase the traffic to the new models and decrease the traffic to the older model. So that's how you do the rolling update. So in this inference graph, you can also see, apart from this Canary testing, they have also utilized the other components of Seldon, that is outlier detection and explanations. So you can also integrate these particular models into your pipeline, so that the incoming request is routed to all these feature transformations or outlier detection, drift detection, explanation, all these things based on the capability provided by Seldon. So that's what this inference graph means. And finally, this is the part of analytics, monitoring the model's metrics using Seldon Core analytics. So usually Prometheus is used to scrape the metrics of the model's metadata. And we try to visualize these model metrics with beautiful dashboards in Grafana. So even Prometheus provides the line chart and graph, but those are not the UI or the user experience with those graphs are a bit less. That's why there is a updated UI that is provided by Grafana. So most of them, they in production, they use Grafana to visualize what is happening in real time.
And then do you also use Prometheus to scrape the data, or only Grafana?
No, Grafana can't scrape the data. Only Prometheus can scrape it. Grafana can just use any of these tools as a storing database and try to visualize. So Grafana is just a visualization dashboard, which has to be integrated with a scraping tool like Prometheus.
I think we actually, I think we also have a Grafana instance on production, but I'm not sure. I think we used to have it.
There should be, because it is not like we just monitor these models metadata. So Grafana, like whatever the kind of metrics that you give, right? It just tries to be make the dashboards based on that. So usually I have seen people using Grafana dashboards even to monitor your deployments. Like suppose your Kubernetes cluster. So there are lots of deployment services and the CPU usage, memory usage. All those things in your Kubernetes cluster are also like we are supposed to monitor in production. So that whenever some error happens or outage happens, it will be useful for you to drop down where the error occurred based on these dashboards as well. So that's where the applicability of Grafana is. Okay, finally we'll show the demo. Yeah, this Prometheus. Okay, this is for Prometheus. This is for Grafana. So you can see all the metrics are getting scraped. I guess before that I'll show how to configure the data sources. So here you can see Prometheus is the data source that I have configured for Grafana. So whatever the Prometheus is scraping at this particular endpoint will be taken as an input to Grafana, and it will try to fetch those metrics and build the dashboards. So you can mention these details over here. So access, usually it would be server. You need to take it to browser if it is like a local Kubernetes cluster. But as and when you have things in remote locations in AWS clusters, you will be having a load balancer endpoint where you are supposed to enter the load balancer endpoint over here, and that would be a server. And HTTP GET. So this would be usually the post. You need to set it to GET because it is trying to fetch the metrics from images. Data in prediction analytics. Okay, so here you can see the number of requests that are coming onto these deployments. So here you can suppose if you have lots of deployments and lots of images, you can just try to set up just the one that is interest of you. So right now, since there is one, I can just click all, but you can filter all those things, even the versions. Suppose a particular model you have plenty of versions, it might mess up the charts. You can just click on which version you want. And coming to this one, so here you can see the number of requests that are hitting these models. So there are basically two models for Canary testing. So that is, so I'll show the deployment file later. So here I have given the traffic split to be 80:20 ratio. So here you can see after some time this graph would saturate at 10, and the below graph would saturate at 2. So usually if there are 10 requests, 2 are going to the model B and 8 are going to model A. That's what the separation that you can see from these charts. And the reward. So this reward is it is a custom definition that I have given. Suppose the models are trying they have predicted the values exactly as what it was expected. Then those models will get a higher reward, and if it is not trying to predict the same value as expected, it will be assigned a lower reward. So these are helpful. Suppose you have two models, model A in prod and model B is supposed to be in prod right now. So model B's agenda is like an improvement to model A based on accuracy. So model B is supposed to get a higher reward compared to model A, right? So that's what the agenda is. So when in production, you can just view these kind of graphs and try to conclude whether the model B, which has improved accuracy with respect to model A, is serving the purpose or not. So, so the agenda can be anything. So you can define the function based on that and try to visualize if there is an improvement or not. And latency as well. Suppose you have model A, which is an unoptimized version, and model B, which has been optimized with Onyx, and you have quantized it, everything. So the agenda was to minimize the latency. So based on that, you should be able to see the difference over here. Model A, what is the latency? Model B, what is the latency? And you'll get to know whether it is serving the purpose or not. If not, then you need to get back and try to work on it. And after that, that rolling update will happen. That's what we can see the conclusion. So here you can see it is almost getting saturated at these levels. Yeah, any questions on this? I guess I can show this in a broader view. So here you can see, suppose if I copy paste this. Oh, I need to give these names as well. Okay, that's fine. Yeah, so here you can see the metrics. So these are the same metrics that is being used by Grafana as well. But here you can see the user interface compared to the one that I showed here. So that's why this is just a metric scraping tool and this is a visualizing tool. So you can use all these things. So if you just try to type Seldon, you'll be able to see what all metrics are being recorded. So based on these metrics, you can just apply some formulas and get those charts running. Suppose here, this is the number of requests that is coming in 5-second interval. So here we have put a rate. So what this does is whatever the number of requests that are hitting these models in 5-second intervals, it will just record it and try to average it out based on the different model versions. So that's what you can see, the average of these two models. Yeah, and this is reward is based on the reward signal that I'm giving it. So based on that, I will try to scrape it, and in 1 minute intervals, whatever the average reward is there, it will try to average it out using the rate. Yeah, that's it. I'll also show the code base. Before that, if there are any questions on this, I'll try to answer.
Nice. Yeah, I do have a question. So from what I can see, it takes quite a bit of setup compared to like an approach that we have now. So would you say this Seldon approach would be a good option for some of the future services, or maybe for all of the services? How do you think about that?
No, I might be biased because I have worked with this before as well. So if there are any equivalent tools I'm not aware of, I see this as the only open source tool with so many capabilities that are required for any of the MLOps production pipelines. But there might be enterprise versions which are a bit more capable of this. But obviously, what more can you expect from an open source which has all the capabilities?
Yeah, and if it's open source, then and it's a good option, then open source is always better, I guess.
Yes.
But then would you say this would be really useful for autocomplete, or maybe not for autocomplete, but maybe for like suggested communities or some other service?
No, this is not specific to any kind of requirement like models. So this is like what you can say. So I'll put it like this. So whatever kind of model it might be, so this is more like a model management tool or platform. So it might be a deep learning or machine learning, whichever kind of model. So you can try to, so these metrics, right? These are like independent of the kind of model that you build, right? The reward or request per second or latency or whatever the metrics that you want. So these are independent of the kind of model that you build. So we can obviously use this for everything.
Yeah, but would you say that's worth the time to set up? Because I mean, if we're going to work with this.
Yeah, it might seem there is a lot of setup, but that's what I mentioned, the Helm repositories or the Seldon analytics. So they have tried to minimize your ops setup effort a lot. I guess it should not take a lot of time to do all this, because since I had done it before, like a DevOps engineer, since he would be well versed with all of these, he should be able to do it in less time compared to me as well.
Okay, nice.
And
And then
since you mentioned Prometheus and Grafana are already in production, so there is no need to deploy them again. So it is only the individual bits and pieces that we need, we have to deploy and integrate.
nice. And then would you think, for example, the autocomplete would be a good first use case for something like that, like this?
Definitely, because we have less data for autocomplete, right? So we also, like since I mentioned the outlier detection, drift detection, and explainability stuff, all those things. So those are very essential when it comes to like build confidence with your customer. And it is also useful for you to drill down what is happening to debug your particular model which you have trained. Because if you're not detecting the outliers or the drift that is happening in the data, and you just try to see why the model is failing, it is not going to like give you the right solution, right? So even if you try to retrain the models a lot without detecting the outliers and drift, you would not be able to conclude what is exactly reason. So these are all like steps of debugging itself, which we can see it as engineers.
Yeah, yeah. And I think then for services such as the autocomplete and suggested communities, they update quite often. I think for those kind of services, it would be great. And then,
Yeah.
for example, we have like the 0-shot classification, but that one is quite static, right? So this would be maybe a bit
So
of an
whichever
overkill.
we have trained, then it requires a lot of monitoring. Whichever is a pre-trained model, it might not. No, it might as well, like, but not 0-shot, because 0-shot, what else implements can you do?
Yeah.
Yeah.
Okay, cool. And to set this up, yeah, we need probably a little bit help from ops. That would be easy.
Yeah.
And other than that, what else do we need?
Other than that, what else we need? Coordination with the ML engineers.
Okay, yeah.
Yeah.
But this is nice.
And
These colors.
as
It has a
well,
bit of the flow colors.
yeah.
with the pink.
Yes. I'll show the deployment file as well. Okay, so any more questions on that? Otherwise, I'll jump on this thing.
Yeah, I'm good.
Okay.
No.
Yeah, so this is the deployment file that I've given for Canary. Here, as I showed in the slide, it is just similar to that. I have given it a Seldon deployment, name of the app. So these labels are important for your services to identify for which deployment that particular service is in place. So that is the use case. So you need to be very important, you need to be very sure what kind of labels you are mentioning in deployment file, so that it should be the same in the service files as well. And this is an interview question as well, so you can remember this. And apart from that, these are the containers. I guess there are two models, so there should be two containers. So this is the first container with the Wines classifier model version A. These are the configurations that I have provided, liveness probe and readiness probe. So since I'm using MLFlow server, which is a prepackaged inference server, so each time you try to switch on the containers, all the dependencies and everything in that particular container will try to install from fresh. Suppose you don't have this prepackaged inference server, you have a Docker image built with S2I, then each time you restart the container, it will just try to run that particular environment file that you have mentioned, and the service will be up and running within a few minutes. Maybe it should not take more than 2 or 3 minutes. But if you choose the route of prepackaged inference servers, then it will try to install all the dependencies, and after that it will try to download the artifacts. If it is there in the persistent storage, it will try to fetch it from there itself. But if it's not, then it will try to download them from the remote locations. So if you use these prepackaged servers, to get these pods up and running, it might take a bit of time depending on the kind of dependencies and the network bandwidth. So for me, it took around 15 to 18 minutes to get this particular pod running. That's why I have set these limits for liveness probe and readiness probe very high. Otherwise, the container would go into like a crash prematurely, even though there was no issue. So these are the things that you need to deal with while deploying your models based on the model size as well. So if you are trying to deploy a deep learning model, suppose its size is in the order of GBs, you need to set these limits a bit more as well, so that you give sufficient time for the container to download those artifacts before prematurely failing it. So that's it. So there is another container, model B, with the same set of configuration, and the artifact. This is a different artifact. This is a different artifact, and replicas one and traffic. So this is the parameter that you try to mention for Canary or A/B testing. So how much traffic you need to route to a particular service. So that's how it's made. And one more important thing is when you have lots of containers and lots of models in a particular deployment, it is important to identify the Kubernetes has to understand which graph is for which container, right? So that is helpful with this particular name. So container, you need to give the name of the container, and in the graph, you need to give the name of the graph. So whichever graph name matches the container name, then Kubernetes will understand this is for this particular container and tries to match it and deploy. So that's how it will be. So there are lots of matchings that go in these files. So that's how Kubernetes works. So you need to be very particular and aware of all these. It might be labels or any kind of metadata or names, anything it might be. I guess I can show. Yeah, so these are the pods that are present in Seldon monitoring namespace. Here you can see Prometheus and Grafana, and the alert manager, which supports Prometheus in scraping the metrics. So all these are pertaining to Prometheus itself in scraping the metrics. Apart from that, models, Seldon monitoring, Seldon system. Yeah. So this Seldon system namespace has the Seldon controller manager, which I discussed in the slide, which has the complete administration kind of an access to all the Seldon based deployments. So it controls everything based on Seldon. And here you can see two models for Canary, model A and model B. And logs, maybe if I can show. Yeah. So these are the logs for that particular container. So whenever you turn on the cluster, so you can see all these things will try to get installed in that particular container. So that's why it takes a lot of time. So you can see all the installations that are happening over here. So there will be an ML model file with the requirements. So you can see all these in place. Just a second, I'm coming back. Okay, I'm back. I'll share my screen again. Yeah, I guess that's it. So based on these logs, you can see what is happening and try to debug if the container prematurely fails. So so that you can increase the limits of liveness probe and readiness probe. Maybe we can show. So these are the two things you need to remember, like while debugging, you can either use the logs or you can describe the parts. So here you can see what all things are happening while deploying a particular container part. So there are 3 steps in Seldon. The first is model A initializer. So there will be an initializing container which tries to download the artifacts. So usually this tries to overcome the disadvantage we have with those liveness probe and readiness probe. So the initializing container itself tries to download the huge model artifacts and tries to store it in persistent volumes. After that, you can see the next. This is the init container, you can see as mentioned over here. And this is a vines classifier. So after you download the artifacts with the init container, so you can see what kind of image it is using, what how it is configured with Prometheus and Grafana, where it is scraping the metrics. So here all these things you can see over here. So here you can see the endpoint for Prometheus where it takes all the metrics. And you can even increase these limits. Suppose you have huge model files and it is consuming a lot of CPU and memory. So you can increase these limits as well. So there are lots of reasons why a container or pod might fail. So it is we need to be aware of what all things has to be configured so that the pods will not fail while deploying it. Yeah, that's it, I guess.